lateral surface area of a triangular prism. First thing, let's go ahead and check out the vocabulary. We're going to start off with what we call a net, and here we have a flat rectangle. Now I'm going to go ahead and draw two lines, and when I do that, I'm going to end up with three rectangles. We're going to call these the lateral faces. Your lateral faces will be rectangles. Now you're going to notice that I added two more shapes. These two shapes are on opposite sides of each other. These are your bases. Because your bases are triangles, then this prism is going to be called a triangular prism. So if the triangles were pentagons, we would call it a pentagonal prism. Or if the bases, the red ones, were rectangles, we would call it a rectangular prism. But since they are triangles and because they're opposite from each other, they're called triangular prisms. Now let's say that you want to take this flat piece right here and we want to fold it up to give it more structure to it. We would have something called a 3D figure. The 3D figure is also known as a polyhedron. And basically, you can see more dimensions. You can see the length, the width, and the height in a 3D figure. Well, here we have our two bases. They are opposite from each other. And we're going to go ahead and connect the corners. Now, the corners, we call these vertices, or for one, a vertex. So I just connected these two vertices right here. And we're going to go ahead and do the same to the other vertices on that triangular prism. Now, the next thing we're going to look at is, let's look at one of the lateral faces. So right here, I'm going to go ahead and shade this. So this right here, if we look at the 3D figure, is represented by the shaded part on the bottom. So although you can't really tell, this is really a rectangle. The bottom of this prism is a rectangle. It looks like a parallelogram, but it's going to be a rectangle. I mean, a rectangle is still a parallelogram, right? But this right here would be a rectangle. Now over here, if we were to fold this up, this vertex would connect with this vertex. This vertex would connect with this vertex. Now where can we see this here on the 3D picture? Well, we actually see it here in the yellow portion. So that's that rectangular part that's a little bit slanted. Okay, you can think of a tent. A tent usually has that little slant. All right, how about the other one that's represented here in orange? Well, that's going to be on the opposite side, and I'm tracing it here in orange, and that's going to be that rectangle on the opposite side that's slanted. So by looking at this polyhedron or this 3D picture, we can see that there are three rectangles. Those are your lateral faces, and you have two triangles, the two bases. Now, this is the formula for lateral surface area of a triangular prism. Perimeter of the base times the height. So we're going to go ahead and label that. And we are only finding the area of the lateral faces, which are your triangles. Which are your rectangles. So capital P is the perimeter of the base. H is going to be the height of the prism. So here's a triangular prism. The two bases are opposite from each other. The bases are also connected by the height. So the height of this prism is 10 centimeters. The side length of the base of one of the sides is 3. Side 2 would be 4. And the third side of the base is 5. Now, this is a right triangle, so if you've already learned about the Pythagorean theorem, 4 centimeters is one of the legs, 3 centimeters is your other leg, and on the opposite side of your right angle is your hypotenuse. So the 5 would actually be your hypotenuse. All right, so we're just going to go ahead and use this formula. Here, we're going to find the perimeter of the base. And then we're going to multiply that by the height of the prism to get surface area. So we're going to go ahead and add the perimeter of the base. The first side is 3. So we're going to label that on the side. plus 4 centimeters, that's your second side, plus 5 centimeters, that's your third. So we're going to add this, and we're going to get a perimeter of 12 centimeters. So we're just going to go ahead and substitute that for the perimeter. My perimeter is 12 centimeters. Again, we just added 4 plus 3 plus the 5, and that gave us the perimeter. Now we're going to multiply that by the height of the prism. Again, here are your two bases. What connects them is going to be your height. So your height is going to be 10 centimeters, and it's labeled here in blue. So we're going to go ahead and substitute that for our height, and we get 10 centimeters. Now the last step is going to be to multiply. So 12 times 10 is going to give us 120. And since we're multiplying centimeter units times centimeter units, we're going to end up with centimeters squared. Okay, this is going to be the lateral surface area of the triangular prism. So once again, lateral means that you only found the area of the 3 rectangles that wrap around this triangular prism. What did we not find the area of? We did not find the area of the base on top and the bottom. So for this lesson, we only focused on finding the lateral surface area, which would be this rectangle in the front, the rectangle in the back that I'm tracing here, and the one on the opposite side in the back. That is the lateral surface area that we found. We found the area of those 3 combined rectangles. Okay, so that'll be it for today's lesson. If you have any questions, please post something in the comments.